Drugs are chemicals that change how our bodies work. Think of them like messengers carrying instructions to our cells, but these messengers need a specific target. Receptors. Receptors are like tiny locks on the surface of our cells. Drugs act like keys, fitting into these locks and either activating them or blocking them. This interaction triggers a cascade of events leading to the drug's effects. Imagine you have a headache. You take a painkiller and it travels through your bloodstream until it reaches the specific receptors in your brain responsible for pain signals. The drug binds to these receptors, effectively reducing the pain you feel. Drugs can act as either agonists or antagonists, depending on their effect on receptors. Agonists are like turning the key and opening the lock. They activate the receptors, mimicking the action of naturally occurring substances in our bodies. For instance, morphine, a powerful painkiller, acts as an agonist at opioid receptors in the brain, producing pain relief and a sense of euphoria. In contrast, antagonists are like putting the wrong key in the lock. They bind to the receptor but don't activate it. Instead, they block other molecules, including agonists, from binding. Antihistamines, used to treat allergies, are a prime example of antagonists. They block histamine, a natural substance released during an allergic reaction, from binding to its receptors, thus reducing allergy symptoms. Interestingly, our bodies are also drug factories, producing a wide array of chemicals that act as drugs within us. These are called endogenous drugs. For example, our brains produce endorphins, natural painkillers released during exercise or stressful situations. Insulin, crucial for regulating blood sugar levels, is another example of an endogenous drug. On the other hand, many drugs are not produced within our bodies. These are called exogenous drugs and are derived from external sources like plants, animals, or synthesized in laboratories. Aspirin, derived from the willow tree, is a well-known exogenous drug used for pain relief and reducing inflammation. Similarly, penicillin, an antibiotic, is derived from a fungus and is used to treat bacterial infections. It's crucial to remember that any substance, even water, can be harmful in excessive amounts. As the saying goes, the dose makes the poison. A small dose of a drug might have beneficial effects, while a large dose of the same drug can be toxic. For example, while a small dose of aspirin can relieve headaches, a large dose can cause stomach ulcers and even be life-threatening. Poisons are substances that have harmful effects even in small doses. Toxins are poisons that are specifically produced by living organisms, like the venom of a snake or the toxins produced by bacteria. Inorganic poisons, on the other hand, originate from non-living sources such as heavy metals like mercury or arsenic. Understanding the nature of drugs, their interactions with our bodies, and the crucial role of dosage is essential for their safe and effective use.